This is our Engineering 183 class where the students design a roller coaster. First they model it with physics and then they construct some design using some CAD software, and then afterwards they build their coasters and test them. We have sensors that are instrumenting the coaster at various points to measure the velocity of the ball as it goes along the track. And they're entered into the computer through a digital acquisition system, and then they compare the actual speed that is measured from the sensors versus the speed that they theoretically calculated, and then calculate a percent error. So this is their design project for the quarter.
Alright, hi, we're Group D. My name's Nichole. This is Gentry, Shawn, and Tom, and this is our roller coaster. Our roller coaster is approximately 7.6 meters long and stands at a height of 112 centimeters. It has a top speed of 2.5 meters per second, and it has 10 features which were specifically designed to wow and thrill the passenger. So please sit back and enjoy the ride while Tom and Gentry explain the features.
We started at a height of 112 centimeters, came down into a upward double horizontal loop. In that loop, most of our losses were friction amplified by G-forces due to the speed. Coming out of that, we dropped down into a vertical loop. In that, the losses were again friction, a little bit of G-forces, and then into an upward horizontal.
On the second half of the roller coaster, since we consumed so much energy at the beginning of it, we kind of made it a downward slope into our final end, our box down here. However, when we came up to the box, we still had a little bit of energy, so we added in a bump that is 4 times as long as it is high to consume some of that energy, and we also had another upward turn right there to slow it down as it entered the box.
A couple of the challenges we faced with building this, first of all, we had a lot of speed coming out of this helix. We had to figure out how to slow this down so the ball stayed on the track. One of the other challenges we had with this was we were given a limited quantity of pieces and parts to build this with, so putting it together with those parts we found a bit challenging. One of the last big challenges we had was being able to slow the ball down enough to drop it into this box, which was one of our requirements. So those are some of the challenges. You guys ready to see this thing run?
Yeah.
All right, let's do it. Gentry,
No.
you get the honors, sir.
Okay.
Yeah, and the box had to be 3 inches basically from where the track was. So the top of the box to the end of the track had to be 3 inches.
We're already getting sick.
Hey! Good job, guys.
Very good.
Wow.